question 6. So, part 1, so just set up your little diagram to gather your thoughts. I'm having left to right being positive, right to left negative. So our just using conservation of momentum, given that these are both travelling at the same speed, which I'm calling x, we can work out that x is 0.4 meters per second. Now for part 2, part A, it is given us so that one particle is at rest immediately after the collision. So first of all, just gather your thoughts. We know that the momentum of P is 1.2 in this direction and Q is 1.0 in the other direction. So the net effect is going to be left to right. Now P can't overtake Q, so it must be that P comes to rest and that Q is in motion. So bearing this in mind, our left hand side stays the same, but our right hand side, we've now, the momentum of P is now 0 because it's at rest. So Q is 0.2 times its speed, so that allows us to work out that V is 1 meter per second. Now for part B, find the time taken after the collision for the moving particle to return to its initial position. So just think what's going on. They're 3.6 meters apart. The net speed they're going at, well, this is going 4 meters left to right, this is going 5 meters right to left. So the net speed is 9 meters per second. So they're actually going to collide after 0.4 seconds. So for how far has Q travelled in 0.4 seconds? Well, given it's travelling at 5 meters per second, it will have travelled 2 meters before the collision. Now we know it's travelling at 1 meter per second after the collision, so how long before it to get back to the same place? Well, it's going to be 2 seconds because it's 2 meters to go at 1 meter per second, so that's going to take 2 seconds. Now part C, this is our sketch. So P starts off at 4 meters per second positive, but then goes to 0. Q starts off at minus 5 meters per second, but that ends up travelling at plus 1 meter per second. So the graph should look like this. For what it's worth, you could have put in a value here for T being 0.4, but you don't need to.